Why do stars twinkle but planets don't? I've noticed when I look at the night sky, stars seem to twinkle, but planets like Jupiter or Venus look steady. What causes this difference? Is it something about the atmosphere, or is it related to how far away they are? I'm not super familiar with astronomy, so I'd love a clear explanation of the physics behind this. Are there conditions where planets might twinkle too, or is it always just stars? Any simple analogies to help me understand would be great. Stars are very far away, so are only point sources of light. Planets, on the other hand, while with the naked eye, aren't point sources. This is easily seen when using a telescope, where no matter how much you magnify, stars won't become any larger, but planets you can resolve the disks and some features. Jupiter, for example, has an apparent size of something like 30 to 50 arcseconds. Now with that out of the way, the atmosphere is turbulent. The air is moving quite a bit. Point sources of light are greatly affected by this, so they appear to twinkle. Planets typically cover a large enough area that they are mostly unaffected by the turbulence. Due to their distances, stars appear more point-like in the sky. Planets are closer, and even with low magnification, appear as discernible disks of light. Stars remain points even at high magnifications. Earth's atmosphere affects light from both. And while twinkling is noticeable with stars, it generally isn't with planets. Our eyes just don't have the ability to perceive it. The twinkling, the tiny variations in brightness thereof, the effects of shifting layers of atmosphere, is overpowered by planets' overall brightness, and that they have discernible disks means light is arriving from across the whole of said disks, rather than from a much narrower and more point-like source, as is the case with albeit larger far more distant stars. Planets can twinkle too. This is due to conditions high up in our atmosphere. The closer to the horizon, the more they could appear to twinkle due to traveling through more atmosphere to reach your eye. Because stars are very much closer to being a perfect point source than planets are. Planets present a disk that, with the possible exception of Venus, just marginally, is too small to be discerned with the unaided eye as a disk, but it's a much greater sized disk than what stars present. As to precisely why presenting as a disk of greater than some angular diameter makes the difference between twinkling and not twinkling, I can't, off the top of my head, spell that out, but as far as it goes, it is the angular size of the apparent disk that makes the difference. I think it's roughly because the typical angular size of the distortion due to turbulence in the atmosphere is greater than the typical angular size of the apparition of a star, but less than the typical angular size of the apparition of a planet. It's something like that, anyway. What I do know for certain is that if a twinkling star is greatly magnified through a telescope, it looks sort of like a random lysagous figure, but the dancing about that makes it look like that is on a smaller scale than the disk presented by a planet, so that the effect on the apparition of a planet is that it's still basically a disk, but just quivering slightly at the edge. It has to do with the distance from Earth. The planets we see are within our solar system. The stars we see are in other solar systems within our galaxy. The planets, therefore, when observed from Earth, have a physical dimension as size and the wave fronts in the electromagnetic field of light that is scattered from them and arrives on Earth aren't planar, or the rays of light, which describe the propagation direction of the electromagnetic waves, aren't parallel. On the other hand, the stars, due to their distance, are basically just points when observed from Earth, and the wave fronts of light that arrive are planar, or the rays, which describe propagation of the electromagnetic waves, are parallel. Due to this difference in distance, the light that is arriving from either planets or stars is affected differently by the turbulence in the air. The effects of atmospheric turbulence, in turn, are the cause of the twinkling effect. Stars don't twinkle when observed from outside the atmosphere. Basically, when you observe a star, the light that you see arrives at your eyes, only took a single path, or precisely, still a very narrow bunch of different paths, through the atmosphere, and was therefore affected by the atmospheric conditions along exactly that path. However, when you observe a planet, the light that you see took many slightly different paths, more precisely, a somewhat wider bunch of different paths, through the atmosphere, and the atmospheric conditions over all these different paths average out to some degree.
Don't forget to like and subscribe so you don't miss our next exciting video.